Good day, Rancho Verde. This is Mr. Langston coming to the Algebra 1 CP class, and today is, it's August 28th, and we've got a warm-up. And so my students should have already done this since I'm recording this after the class is all done. So what we've got right here is 3x equals negative 12. So what we're going to do is take both sides, divide them by 3. Remember, we're solving for x, so these cancel out right there. And we get x equals negative 12 divided by 3 is negative 4. We have x over negative 3, and that is equal to 4. So we're going to multiply both sides by negative 3. So when I do that, these two negative 3's, they cancel out. I have x equals 4 times a negative 3, which is a negative 12. I've got negative 5x equals negative 20. Divide both sides by negative 5. The negative 5's cancel out. I got x equals to negative 20 divided by negative 5 is positive 4. I got x plus 2 equals 1. Subtract 2 from both sides. Minus 2 minus 2. That cancels out. X equals negative 1. X minus 8 equals negative 2. Add 8 to both sides. When I do that, those 8's, they cancel out. Negative 2 plus 8. I owe $2, but I have $8. At the end of the transaction, I still have $6 in my pocket. I have x plus 3 equals negative 3. The inverse operation is to subtract 3. That will get me x by itself. So I'll subtract 3 from both sides. That cancels. Negative 3 plus negative 3. I owe $3, and I owe $3 again. So I owe $6. X over 3 equals negative 9. Take and multiply both sides by 3. So I'm multiplying by 3. That cancels out. I get x equals negative 9 times 3, negative 27. Negative 4x equals 36. Divide both sides by negative 4. The negative 4's cancel out. X equals negative 9. And I got x over 8 equals 0. Multiply both sides by 8. The 8's cancel out. And I get x equals 0. So what we're doing is we're solving one-step linear inequalities now. So we're just taking it an extra level. So our focus standard, we're still doing prerequisite skills. Our content standard, we are solving one-step linear inequalities. Our power standard, what we are going to do today is attend to precision. So we're going to make sure that our answers are correct, that we're following the right steps. And lastly, our language objectives. Students will compare how they solve for the variable of equations and for variables of inequalities using multiplication and division, and you will be able to articulate. So it's variables. You'll be able to articulate your comparisons in haiku learning as a ticket out the door, and you should already have done that. So for solving one-step linear inequalities using addition and subtraction, nothing's going to change. It's exactly the same as if you're solving equalities. So you can treat it like an equal sign, but really it's an inequality. So for instance, I have x minus 3 is greater than negative 2. You know what to do. You add 3 to both sides. When you add 3 to both sides, that cancels out the negative 3 and the positive 3. And now we have x is greater than, I owe $2, but I have $3. At the end of the transaction, I still have $1 in my pocket. So I got x plus 4 is less than 3. And again, the opposite operation or the inverse operation of adding 4 is subtracting 4. That cancels out. I have x is less than 3 minus 4, negative 1. I have x plus 5 is greater than or equal to 7. The inverse operation is to subtract 5, subtracting 5 from both sides. I'm going to take and cancel that out. I have x is greater than or equal to, I have $7, but I owe $5. So that means I have $2 left over. I have x minus 6 is less than or equal to 2. I'm going to add 6 to both sides. That cancels out the negative 6 and the positive 6, and I have x is less than or equal to 8. X plus 3 is greater than negative 9. The inverse operation of adding 3 is subtracting 3. So cancels out, x is greater than negative 12. And I got x minus 7 is less than or equal to negative 4. The inverse operation of subtracting 7 is adding 7. So I'll take and I'll add 7. That'll cancel out. I have x is less than or equal to, I owe $4, but I have $7. At the end of the transaction, I've got $3 in my pocket. So now this is where things get a little bit different. It's when we're multiplying or dividing both sides of the inequality. And I'm yawning. Sorry. If I multiply both sides by the inequality or divide both sides by the inequality, and that number that I'm doing it by, that I'm multiplying or dividing by, is positive, then nothing changes. You treat it just like the same. But it's when the number is negative that I'm going to multiply both sides that I start doing some wonky things. So let's look at this. I have 3x is less than 9. I need to get x by itself. The opposite of multiplying by 3, the inverse operation of multiplying by 3 is dividing by 3. So I'll divide both sides by 3. That will cancel out. Now, here's the thing. This is positive. This is positive. Cool. I just go for it. So x is less than 3. That's fine because I took and I divided both sides by a positive value. Now, when I look over here, I have negative 4x is greater than 16. This is multiplication. The inverse operation of multiplication is division. So I'm going to divide both sides by negative 4. This is where you have to pay attention. When I am dividing or multiplying both sides by a negative number, the direction of the inequality flips. In this case, it's pointing to the right, so it's now going to point to the left. And now I just go ahead like normal. Cancels out the 4, so I'm left with x, and now I have 16 divided by negative 4. So I have x is less than negative 4. I'm sorry about the yawning. I apologize. So for this, I have 6x is less than or equal to negative 36. I'm going to divide both sides by 6. And I divide both sides by a positive, so I don't have to do anything special. I have x is less than or equal to negative 6. And over here, I have negative 5x is greater than or equal to negative 25, so I'm going to divide both sides by negative 5. And just like I told you, I divided both sides by a negative. So this inequality switches direction. It was pointing to the right, so it now points to the left, and then I just continue on as normal. So I have x on the left, and I have negative 25 divided by negative 5, which is, oops. I almost made a mistake. It's positive 5. Positive 5, because negative divided by a negative is a positive. Now what I have down here are samples of inequalities where the x is on the right side. I'm having you guys write your answers on the left side, so you have a choice. You can switch these and make it so that the 9x is on the left and the negative 18 is on the right, but what you need to do is make sure that the inequality still points to what it's supposed to point to. So for instance, it's pointing to the 9x. I need to switch its direction and make it point to the 9x. Now I can solve this just like I normally would. So divide both sides by 9. I'm dividing by a positive, so I'm not doing anything special. So 9's cancel out. I have x is less than or equal to negative 2. I could also switch it at the very end. So in this case, I switched it at the beginning. I put the 9x over on the left. I put the negative 18 over on the right. I could wait to the very end to do that if I want to. It's no big deal. So if I divide both sides by 2, in this case, I'm going to wait to the end. So divide both sides by 2. Both of them are positive, so I don't do anything special. When I do that, I have 8 is less than x. Now I can take and move that x to the left side, move the 8 to the right side, and then don't forget to switch the direction of the inequality. So it doesn't matter. I can move it at the end. I can move it at the beginning. I also have 24 is greater than or equal to negative x. So doing that, I'm going to take and divide both sides by negative 8. When I do that, I'm switching the direction of my inequality because I divided both sides by a negative. So the inequality now will point to the left. And I'm just going to continue on as normal. 24 divided by negative 8, that's negative 3. And I have x over on the right side. Now, I'm going to want for my final answer to put x on the left because I want you guys to do that. So if I put x on the left, I'm going to put negative 3 on the right, and I need to make sure that the inequality still points to the negative 3. Lastly, I'm going to change this one at the beginning because I want to. So I have negative 3x. 15. That way I'm getting my x already on the left side. And I need to make sure that my inequality still points to the 15. Now I'm going to take and divide both sides by negative 3. So divided by negative 3, divided by negative 3. So that cancels out. And again, notice I divided both sides by a negative. So my inequality changes direction yet again. So I've got 15 divided by negative 3 is negative 5. X is less than or equal to negative 5. Now I have this slide here. I have x divided by negative 2 is greater than or equal to 6. I'm going to take and multiply both sides by negative 2. So when I multiply both sides by negative 2, notice both sides are being multiplied by a negative. So I switch the direction of the inequality. And I have 6 times a negative 2, negative 12. That cancels out. So I have x is less than or equal to negative 12. For this one, times it by 3. That cancels out division by 3. It's multiplication by 3. Cancels it out. And notice, they're both positive. So I have x less than or equal to 36 because they're both positive. I don't switch the direction of the inequality. For this one, times 3 times 3. 3 times 4, that gives me 12. And that cancels out. Both of these, again, they're positive. So I'm not going to switch the direction of my inequality. I'm just not gonna. So less than or equal to x. 12 is less than or equal to x. I'm going to take and multiply by negative 2. So in this one, I'm multiplying both sides by a negative. So I am going to switch the direction of the inequality. And when I do that, I have x here. I have positive 10. Now, I put these two in because I wanted to show you that you could get an answer that's a fraction. It's okay. It's no big deal. So if I divide both sides by 3, I don't switch the direction of the inequality because I'm dividing both sides by a positive. So I get x, because these cancel out, is less than or equal to negative 2 over 3. And my last one over here, I'll divide both sides by negative 4, which will cancel out there. I get x is greater than or equal to negative 14 over 4. And I'm going to simplify. Both top and bottom, they're both divisible by 2, so I'm going to divide top and bottom by 2. And that's going to give me x is greater than or equal to negative 7 over 2. And now I'm going to go to my side, and I'm going to be, how many times does 2 go into 7? Well, it goes 3 times. 2 times 3 is 6. Subtract it. Remainder 1. So that means x is greater than or equal to, oh, I gotten so fast that I didn't even pay attention. I divided both sides by a negative. Guess what should have happened here? Yep. I should have switched direction of my inequality. Didn't even notice that. Almost slipped past me. So negative 3 1/2. All right. So you have your haiku learning discussion that you need to complete. It's your ticket out the door. So with your elbow partner, compare how multiplication and division on both sides by a negative number with linear equations is different from multiplication and division on both sides by a negative number with linear inequalities. Then you need to go to your haiku learning webpage and write using your own words on how multiplication and division on both sides by a negative number with linear equations is different from multiplication and division on both sides by a negative number with linear inequalities is different. Okay? So basically what you're going to do is you're going to talk about the direction of the inequality, possibly shifting, switching. So that's all I've got for you today. I hope you enjoyed it. It was kind of short, but you know what? It's nice to get to the point on some things. Sometimes it's not good to be long-winded. And I hope you have a great Monday, and I will see you Tuesday. So, best I can say is Godspeed and peace.